So hello guys, today we are going to continue building our system on our IoT system. So today we are going to build or add the sensors, connect it, collect the data, build our own Node-RED design to collect the data and upload it to Azure. So this is the main target for today. So I'm going to start right away, and this is the sensor I'm using. I'm using pressure and temperature sensor. Same one sensor doing both. So it's BMP 180 atmospheric pressure sensor. It has a pressure and temperature sensor at the same time. There are two versions of it. There is one version with 5 pins like this one, and there is another one which is 4 pins. I am using the 4-pin version. The difference is extra 3.3 volts here. So I'm using VCC here 5 volts. Ground, and then SCL and SDA connected to my Raspberry Pi. So if you see the Raspberry Pi, or I can show you actually on the diagram right away. So I have it already connected, so I'll show you the full product at the end. So this is the whole Node-RED design. So the sensor is connected here. So let's see the pins, or sorry, this is the sensor itself. There's a node for it. So I connected it on the SCL and the SDA, which are these pins. SDA and SCL are pin 3 and 5 here, plus the ground pin, plus one of the 5 volts pin. So this is the connection between the Raspberry Pi and the sensor I have. So this is the whole diagram. The diagram has some extra stuff, but the main stuff we need is this sensor node, BMP 180. You need to install it. So if you go to the manage palette, and then search and install in BMP 180. So this node set, they have this diagram, or sorry, they have the many sensors. Out of them is this sensor. So they have a couple of sensors, as you see here. One of them is the BMP 180. So you need just to search for your own sensor and include the node if you find the node that it's working for it. So it's better at the beginning to make sure you have a node for your sensor. So this is a GitHub for this contribution. So I installed it. I put it here on my my diagram. So you can see here it's installed. Yeah, this is a node here. So I just drag and drop it here, and I put it on my design. And then we need to. There is not too much configuration, but I found the default is 8x. So I don't think it worked for me. So I had to change it to the oversampling to 4x only. If you enable debug mode, it will put on the console messages, debug messages for you on the console if you have the console running. So it will put some debugging message here on the console while it's running, the Node-RED is running. So the rest is some modification and tweaking for the data. So for example, I have here, I needed to show these diagrams, these gadgets for the temperature and the pressure. So let's see the gadgets here. So I created these gadgets. So one chart here for the pressure in Pascal and the pressure in a donut chart. And then another one for temperature and donut chart for it. So how to do these? So I have here these nodes, so you can install them also. It's called the dashboard node. So you need to install this dashboard. It gives you all of these nodes. You can use them to visualize your data. So I put one of them, which is this gadget here, as a gauge, and one of them is a chart. So I put 2 of these here, but for this you need to give it the actual value right away in the payload. So this is a label for it, temperature and series, in Celsius, and then also the group is the column where you put on the layout. So I have two columns here, so I put it here in column 2 in my UI. Then put the maximum and minimum and any other configuration you want. So, but to adjust the value, I need to give it the direct value. So the value coming from here are in a JSON structure, so which has all data. So I put here this modify or a change node to modify the payload.tc and to give it or move it to the payload itself, because I need only the TC, which is the temperature in Celsius, to give it to these two gauges. And then the same one or similar one to move the payload.pressure or P to payload. So give them as only the pressure to these two gauges. So that's it. And then we can see here the gauges are showing the pressure and temperature as you see. So we can see the layout of the dashboard itself. It's one of these here. So the dashboard, I have two columns in the dashboard. I can add more columns, and also these are the gauges I have on my layout. Okay, if I change it any order here, it will affect right away the UI. The UI, to access it, you just go to Raspberry Pi.local colon 1880/UI/UI. This is what you need to write to get access to this UI. So it adds the /UI compared to this one, it's just without the /UI. Okay, so this is the layout. If I change it any order here, I can modify my layout of my design, of my UI. So this part, I think, should be more clear now to understand. And these nodes are the change nodes, which are here. So I have here the change node, which is one of the built-in functions. You should have it already. So I just put it here and do what I showed you. Then here, this is a inject node. So it's injecting for this sensor. It needs to inject a payload of measure to have this sensor measure the data. So you just send a measure keyword or a measure payload to this sensor to get the data. And then at the same time, I'm repeating the message every 10 seconds. So I'm sampling every 10 seconds the temperature and the pressure and send the output to my gauges. And at the same time, I'm taking the same message and removing from it, because I need only the pressure, temperature, some extra data I don't need because these are derived data, so I don't need them. The pressure in another unit. Here is the temperature in Fahrenheit, timestamp, altitude. I don't need these data, so I just remove them. They are all already calculated. So I remove them, I deleted them. Then I give the output of my sensor to a function here, and this function is preparing my data to be sent to the Azure IoT Hub. So the function here I have, this is the code I have here. And because the sensor is also sending me, which I think it's a bug, they are sending me the measure message, which I don't need. So I want to skip, if there is a payload equals measure, I skip that. So I return null, so skip it. And also I have a flag to say log, should it log to Azure or not. So if it's yes, if it's true, it's going to log, so it will go here. Otherwise, it will skip. So if it's no, because I have the exclamation mark here. So if it's no, so it will return null, so it will not also log to Azure. Then this line is not needed. Actually, I just put it here as a trick for training, because I need to collect data for training. So for training purposes, I have added a switch. So I set the switch when the data is in a certain condition. I assume it's when the data is in a critical situation. So I set the switch, and at the same time, I check the temperature should be higher than 40 Celsius. Otherwise, it will say it's not critical. Put 0 if it's the case is this one. If the switch is not connected, or if the temperature is less than 40, so I say it's not critical case. So this is just for training purposes, because I didn't want to mark or label the data manually, so I just added this for training purposes. For actual production, we should remove this field. The rest is just to create the data. You have to put your own device ID from Azure here and your key from Azure for your IoT device. So you need to replace the device ID and the key using your own data. And that's it, and it prepares the data and sends the data to Azure. So this is for this function node. Then the output is sent right away to Azure. Here also you need to put your Azure IoT host name, the host name from your Azure IoT. So, and yeah, once you have this in, this now should be able to send the data to Azure. The rest is, this is a logging node. This is just a trigger, half-second trigger to flash an LED when we get a message. So and also this is a switch to log to Azure or not. So for this switch, when I set it, it set here a function. With the function sets a variable in the flow itself. So flow.set, I set a variable here with the payload. So if the payload is the switch is connected, it will be high or 1, and if the switch is not connected, it will be low or 0. That's it. So, and this switch is here. We can see it. This log to Azure. So if I click it like that, so it will be high. So now it's going to log to Azure whenever it gets each 10 seconds sample. It will upload the data to Azure. And because the switch I set to 0, you see here it says message sent. So the switch for training purposes, I connected it now with 0, so it's not critical. So it will always be a 0. The critical case will be 0. So if the switch is high and the temperature is above 40 degrees, so it will say critical here 1. Otherwise, critical will be 0. So it needs to be critical to be 1 here. The switch is connected, and also the temperature is higher than 40. So you see here it's logging to Azure. If I don't want to log, I can just disable this button, turn it off, so it will not log to Azure. So yeah, this is a button you see here is a button is off because I turn it off. So it sets the flag to this global flag or flow level flag. Log to Azure, set it to the payload 0 or 1, and also it's checked here in the function. So in the function, I have a flow.get instead of set. We have get here log to Azure flag. So if it's set, if set to 0, you get exclamation here, so it will cancel. It will not log. Otherwise, if this is 0, it will be turned to true, and it will cancel here. It will not log. If it's high, it will be 0, so this will not run, and it will go here and log to Azure. So this is a logic we have, and then this is a message show notification. If there's any error in the system, it will show me notification here, and this notification is from the dashboard also. So notification node. So this is the one. So if there is any error, it catches error. This one catches all error from all node, so it will show it as an error, and also gets the message here, message sent, and show it as a notification for us. So this shows on the right top corner of my dashboard. So if you go here, see again, so it shows here. If I enable this, it shows here if it's a critical situation or not. So message sent. So because the switch actually I don't have access to it, it's connected on my house. This is actually connected to a remote desktop, but I can start my machine through I have a thermostat, smart thermostat. So I can start the heater at my home. So you can see the temperature is going, it will go up. And the pressure also should go up. So we see here the temperature is going up. And it's being logged onto the Azure. So we can check it also on Azure. Here it's collecting data in my blob storage. This is one. So this is our blob storage. It's collecting data in JSON format. If we go there and click edit, you can see the data collected here. And if we go down, this is the current or last reading. So 1293, if I refresh. $12.95. So it adds each time it adds one line. Adds one line at a time when it logs. So you see here the temperature is going up, and also the tip pressure is going up. So that's it for the setup, for the hardware setup, which collects the data. And I'm collecting data now for training. So I added this critical button. So I have this button, a button connected on one of my pins on Raspberry Pi, and this pin is connected, pulled up. So this is a critical pin, which is this one. I connected pin 40, and I have it pull up. So what's happening is when it's critical, I leave it disconnected, and then when it's not critical, I connect it to the ground next to it here. So I short it to the ground, so it will be 0. So it means it's not critical. If I leave it floating, it will be pulled up, so it will be critical. So this is only for training purpose. Once it's I collect the data, I don't need this part, because we are going to use the machine learning to detect the current situation. So you see here the temperature went up, and the pressure also is going up on my gadgets. I turned my machine down, the furnace, so the temperature should go down now, and also the pressure. That's it. So now we are collecting data for training. Next, we are going to use the data to train a machine learning model. Then we can use it to detect the critical situation once we have. So for sure, we need to collect data while it's critical or not critical. So I need to collect data in different situations over a good amount of time. Usually, it's better to have some balance between the critical and non-critical data, because if you have lots of non-critical data and not too many critical, so it means the system will be more biased. So it's better to try to balance between the two cases. I have only two cases in this example. So usually I try to control it, so to make sure my data is going okay, is balanced. And thank you for now.